Today we are going to see the last section of chapter 3, that is about the relative motion of an object. What does relative motion, what does it mean? What is the meaning of the relative motion of an object? So when we talk about motion, we need to have a frame of reference. So whenever we are talking the motion of an object, we have to have an object by which, against which we can compare or relate our motion. So look at this guy. This guy is sitting inside the car on his train. So like when the window is closed, like he is looking at his computer. So relative to his computer, he is at rest. But when he tries to open the window to remove the curtains and look at outside through the window, he feels that he is in motion because when the time he looks at outside through the window, he feels that the stationary objects are moving back with the same speed through which the car is traveling. So whenever we are talking about motion, we need to have a position or a frame of reference, or we need to have a point by which we can relate our motion. Let's say here we have two cars. As you can see from the figure, there are two cars. This is car A and this is car B. Look here, car B is at a distance or at a displacement of xb from the y-axis, and car A is at a displacement of xa from the y-axis. So the distance of B relative to A, or the displacement of B relative to A, is positive because B is at some distance or ahead of A. Whereas when you compare this one, B is like lagging behind as compared to car A. So we will have negative relative displacement. Or generally what you have to do is, if you have two cars, car A and car B, which are moving in the same direction, the velocity of B, car B, relative to or as observed by an observer in car A, is given by the velocity of B minus the velocity of car A. Same thing happens also for acceleration. As you can see here, the acceleration of B as compared by an observer in car A is given by acceleration of B minus acceleration of A. So the velocity of B as observed by an observer in car A is given by the difference between their velocities. Same way, the velocity of car A as observed by an observer in car B is given by the velocity of A minus the velocity of B. So these are the cases that helps us, the ways or formulas that helps us to find the relative velocity of two objects when they are traveling, two objects or which are moving in the same direction. We use this formula provided that the cars are traveling in the same direction. The second case is like the case where we see here in the figure, where the two cars are heading towards each other. See? So in this case, like here, the yellow and the blue car are moving towards each other. They are moving like in the same direction, like they are just heading towards each other, or they are moving in opposite direction. So in this case, the relative velocity of one car, the velocity of one car relative, let's say this is car A, and we have another car this is car A, which is moving at the velocity of A, and we have another car which is moving to the left at a velocity of B, that's car B. So the velocity of this case, the velocity of A as compared to B or relative to car B is the same as the velocity of B as compared to car A, which is the same as the velocity of A plus the sum of their velocities. So this is the case where the cars are traveling in the same direction. We use this formula if they are moving, if the cars are traveling, if they move in opposite direction, or if they are moving in opposite direction. That's why when two cars which are heading towards each other, when they collide, they will have a very catastrophic end or result, because their relative velocity is maximum, or they will have a maximum kinetic energy. So this relative velocity causes or is a reason for the catastrophic end or result. So whenever two cars are heading towards each other, their relative velocity or the velocity of one car relative to the other car is given by the sum of individual velocities. That's why when two cars which are heading towards each other, when we have two cars which are moving towards each other, like if they are heading towards each other, when they collide, we will have a very dangerous end or result. So it's killer accident. It's very dangerous. But when the cars like which are going in the same direction collide, the result could not be as dangerous as when they are moving in opposite direction. Clear? That's what you have to know about the relative velocity of two objects, or the velocity of one object as compared to another object. So we say that an object is in motion, or an object is moving ahead of another object when we have a point or another object against which we can relate our motion. Now let's see examples. Let's see examples. Here a boat is heading north, or a boat is trying to cross to the north of a wide river with a velocity of 10 kilometers. There is a boat which is heading to the north. Like the boat is traveling at a velocity of 10 kilometers in the direction of north. The river has a uniform velocity, or we call it current velocity. This is the velocity of the boat. I'm in the water, that is 5 kilometers per hour in the direction east. So we are asked to determine the velocity of the boat with respect to the observer on the ground. That is the velocity of the boat as being observed by an observer in the shore of the river, or in the earth, on the earth. So the first thing that we have to do is we have to draw a graph. We have to represent this concept graphically. Try to represent this graphically. Let's put it graphically. So the first thing what you have to know is, let's put our coordinate axis. Let's put our coordinate axis, our coordinate plane. So this is our coordinate plane, and we know that the cardinal directions are: this is north, this is west, this is south, and this is east. These are our cardinal directions. So a boat is heading at a speed of 10, crossing to the other side of the river at a speed of 10 kilometers per hour in the direction of north. So the boat is traveling, a boat is going at a speed of 10 kilometers per hour. This is the speed of the boat. The boat is traveling at let's say this y-axis. Let's say this is the speed of the boat. This is the boat. So the boat is going. This is the velocity of the boat. That the boat respective. That is the velocity of the boat relative to the water is given. Like it's going at the speed of this. That is 10 kilometers per hour in the direction of north. And the water is directed to the east, in the direction east at a speed of, this is the velocity of the water relative to, as compared to the earth, that's relative to the earth, with respect to the earth. This is the velocity of the boat relative to the water. And this is the velocity of the water relative to the earth. That is 5 kilometers per hour in the direction of east. So this is a graph. This is how we put graphically. So the boat is going to the north, is heading, crossing to the north, and the water is just going in the direction of east. Now, we want to find the resultant velocity. This is our resultant velocity. This is the resultant velocity of the what? That is. So this is what? The resultant velocity, or the velocity of the boat relative to the ground or the earth. Or this is the velocity of the boat with respect to an observer on the ground. And this is called an angle. You can call it an angle theta. Theta is an angle that the resultant velocity makes with the vertical component of the velocity, or this is the angle that the resultant vector makes with the y-axis or with the north direction. So let's find this resultant vector. So from our trigonometric rule, from the rule of trigonometry, we know that, or from the Pythagoras theorem, for any triangle, this looks like a right angle triangle. It forms an angle of 90 degrees here. It's a right angle triangle. We know that in a right angle triangle, the sum of the two sides, the sum of the square of the two sides is the same as the square of the hypotenuse. That is, the velocity of the boat with respect to the earth is square is equal to the velocity of the boat relative to the water square plus the velocity of the water relative to the earth square. That's how we do it. Now, the next step that we have to do is we take we just substitute the numbers and get the answer. So we know that we are looking for the velocity of the boat relative to the earth is equal to, we take the square root of both sides, the square root of, the velocity of the boat relative to the water is 10 kilometers, that's 10 kilometers square, that's 10 kilometers per hour square plus this square plus, sorry, this is square, I don't think it's clear, let me rub it, like anyways, it's a square. This square plus the velocity of the water relative to the ground or the earth is 5 kilometers per hour. This is square. Now 10 square is 100 plus 5 square is 25. Then 100 plus 25 is 125 kilometers square over hour square under the square root. Then taking the square root of 125, then the velocity of the boat relative to an observer on the shore of the water is given by the square root of, when you take the square root of 125, you can use calculator, you will get 11.18 kilometers per hour. You can use calculator, this is the same as 11.18. You can write 11.2 if I ask you to write your answer in the 1 decimal place. So the velocity of the object or the boat with respect to an observer on the shore is given by 11.18 kilometers per hour. Now, as we know, velocity is a vector quantity, and the vectors they need both magnitude and direction. So we have already solved for the magnitude of the vector, so we are left with the direction. At what angle is this resultant velocity with respect to the vertical component or with respect to the y-axis? So to find the angle that this resultant velocity makes, we use our trigonometric ratio tangent, because we know that the tangent is the ratio of opposite side. So the side opposite to this angle is, this is opposite side, this is opposite side to the given angle, this is opposite side, and this is the adjacent side. So we know that the formula that relates opposite and adjacent is tangent. So the tangent of the given, like tan of theta, is given by the tangent of the angle theta is given by the ratio of opposite side, that's 5 kilometers per hour, divided by, this is 5 kilometers per hour, divided by, because tangent is defined as tan from our trigonometric function or ratio. We know that tangent of any angle is defined as the ratio of opposite side divided by the adjacent side. So the side opposite to this angle is 5 kilometers per hour, that is the speed of the water, the current speed, divided by its adjacent side is the speed of the boat in the north direction, that is 10 kilometers per hour. So you just take the ratio, tan theta is defined as the arctan of, or the inverse, tan inverse, we call it arctan of, when you divide 5 by 10 you will get 0.5. Here it's a pure number because we cancel out kilometer per hour by kilometer per hour. So we'll have 5 over 10, that's when you divide 5 by 10 you will get 0.5. So if this is the tangent value of an angle, theta, but we don't know theta. So we are looking for theta. So for what angle theta is, its tangent value 0.5. That's the meaning. So when you say arctan or tan inverse of 0.5, it means what should be the value of theta so that its tangent value will be 0.5. So you just go to calculator and write shift, then tan, then you get this symbol, the arctan symbol, and write the number 0.5. Then the number that you are going to get is the value of theta. So angle theta is 26. You can use your calculator, you get 26.6 degree. So this is the value of the given theta. So the velocity of the object is, I can write this as, the velocity of the object is 11.18 kilometer per hour at an angle of, we can say that the velocity, shortly we can write that the velocity of the object is, or the boat travels at a velocity of 10 kilometer per hour in the direction of, the velocity of the object is 10 kilometer per hour in the direction of, then the velocity is equal to 11.8, that's 11.8 kilometer per hour, 11.18, I'm sorry, you can see here the velocity is 11.18 kilometer per hour in the direction of 26.6 degree east of north. This is very important. That is east of north. This is very important. So the velocity is defined as, or given by, the velocity of the boat is given by 11.18 kilometer per hour in the direction of 26.6 degree north of east with respect to the earth. This is very important. With respect to the earth. That's all. Let's move to the second example. This looks like similar with what we did before. A boat can travel 1.5 meter per second in still water. That's the speed of the boat. If this boat heads directly north, it looks like the same as what we did before. So this boat is heading to the north. The boat is heading to the north at a speed of 1.5 meter per second. That is, this is the speed of the boat. That's 1.5 meter per second in the direction of north. This is north. We know that this is north. This is west, and this is east. Across a stream with a current velocity, this is the velocity of the water. The velocity of the water is 0.5. It is 0.5 meter per second in the direction of east. So we are asked to find what is the velocity of the boat relative to the shore. It is exactly the same as what we did earlier, except that the numbers are different. This is the resultant velocity. This is what? The resultant velocity. This is the angle theta. So to find the resultant velocity, we use the Pythagoras theorem. That is, we use the Pythagoras theorem. That is the 1.5, the resultant speed square is equal to 1.5 meter per second square plus 0.5 meter per second square. Then the resultant speed, or the velocity of the boat relative, that's, we are just talking, this is the velocity of the boat relative to the person on the shore. So this is the same as the square root of taking the square root of both sides. When you multiply 1.5 by 1.5, we will get 2.25 meter square over second square. Plus, when you multiply 0.5 by, you get 0.25 meter square per second square. So the resultant velocity is given by, when you add this, what you get, 2.25 plus 0.25 will give us 2.25, sorry, you can use calculator 2.25 plus 0.25 is equal to, that is the square root of 2.5. This is the square root of 2.5. The square root of 2.5 meter square per second square. So the resultant velocity, or the velocity of the boat relative to a person on the ground or on the earth, is given by the square root of 2.5. You just take the square root of 2.5 and put the number, you will get almost 1.58 meter per second. This is the resultant velocity. Now our answer is not yet solved, because this is the magnitude of the velocity. We have to look for the direction. What is the direction of the velocity? This resultant velocity. We want to find the direction of the resultant velocity. As we did earlier, what we have to do is we use the tangent. Tan of theta, we want to find the direction. The direction of this resultant velocity is calculated by finding the magnitude or the angle, the value of this theta. So from our trigonometric ratio, we know that tangent is defined as the ratio of opposite side divided by the adjacent. That is 0.5 meter per second divided by 1.5 meter per second. Then tan theta is equal to, take the ratio of these two. You just take the ratio of these two numbers and find, then you will get, you can use calculator, that is 0.5 divided by 1.5 will give us, that is 0.333. Like it's kind of repeating decimal. So to find theta, theta is given by the arctan of 0.33. So as we did earlier, to find, this means what is the value of theta, so that its tangent value is 0.33. That is, you go just to use calculator, you just click tan, shift, then go to tan, you will get this symbol, that's arctan, the arctan symbol, and insert the number, that's 0.333. Then you will get 18.42. So the value of this is 18.42 degree. So this is the angle that this resultant velocity makes with the vertical axis. So this, the final answer is, now I can write the final answer. The velocity of this boat with respect to a person on the shore of the water is given by 1.58 meter per second at an angle of, or in the direction of, or at an angle, you can say at an angle, or in the direction of 18.42 degree east of north with respect to the earth, with respect to earth. So this is a complete answer for the velocity of the object. See, velocity, we know that velocity is a vector physical quantity, and vectors need both magnitude and direction in order to, in order to define them completely. So the magnitude is already solved by using the Pythagoras theorem, that's 1.58. In order to find the direction, I will use the tangent value, the tangent of the given angle theta. What is the tangent of this angle? So finally, the value of this angle is 18.42 degree. So this means the velocity of this boat is 1.58 meter per second in the direction of 18.42 degree east of north with respect to the earth. That's all. That's how you calculate the velocity of a boat which is crossing a given river or a river. That's all what we have.